All right, today we're going to be talking about multiplying matrices. Now, I am going to attach a Word document that has the YouTube stations or whatever to go ahead and how to do multiplying matrices on your calculator. But we're going to step through how to do it by hand also. So our main concept is multiplying matrices. A couple of things that you need to understand. In order to multiply matrices, the columns of the first matrix must match the rows of the second. In other words, it's the inside numbers must match. I'm going to talk about that in just a moment when we see our first example, what that means. I know that's kind of probably a little, what is he talking about right now? Also, the inside number is the number of multiplications that you'll need to be summed. Again, I'm going to show you that. And the rows of the first and the columns of the second will give you the dimensions of the new matrix. So let me kind of show an example and talk about these three things. All right, so here we have two matrices that we're going to multiply together. We have matrix A and matrix B. Now, what's in matrix A, it doesn't matter as of right now. We'll get to that eventually, but we want to know whether or not we can actually multiply them. Remember, when we're adding, they have to be the same size. When we're multiplying, actually they don't. There's another rule that they have to follow, and it's these rules that I just talked about here. All right, so what are we looking at? So we're doing A times B, and the answer, of course, will be whatever the combination is. So A is a 3 by 4, and B is a 4 by 2. So we want to look at the inside numbers, these here, this 4 and this 4. The columns for the first one with the rows for the second one. Those two must be the same. And in this case, they are. They're both 4. Okay? That allows us to go ahead and multiply these. If those numbers were not the same, we cannot do it. Once we've taken these two 4s out, what's left, this 3 and 2, is the answer for our other matrix. So that 3 goes there for that 3, and that 2 goes over there. And those 4s, again, have to be equal. So yes, we can do it, and the answer is going to be a 3 by 2. Let's look at another one. We list them out, 3 by 2 and a 4 by 3. Notice the middles here. The 2 and the 4 are not the same. So we cannot do this. We cannot do. All right. What about this one? 3 by 2 and a 2 by 3. Yeah, these 2's are the same, so we can multiply it. What's left? A 3 by 3. Oops, a little fast there, sorry. So it is a 3 by 3. Let's try another one. A 2 by 3 and another 2 by 3. Now these are the same dimensions. We could add them, but we actually cannot multiply them. The 3 and the 2 in the middle are not the same, so that answer is not defined. We cannot do it. All right, well, how do we actually multiply? The multiplying is actually a really detailed set of steps. It's not hard because it's just some multiplication and some addition, but it's not as easy as it should be. We're not just going to multiply A times E. We're going to do rows the first ones times the columns of the second one. So the first matrix is always about the rows. The second matrix is always about the columns. So let's take a look at matrix A. The rows are the row is A, B, and C, D. So if you look in the first one here, we have A and B and A and B. And then CD is on the bottom, CD and CD. So those are my two rows. So AB twice here and CD twice there. Now I set columns in the second one. So EG, EG with EG, and FH, FH, and FH. So column 1, EGs are here. Column 2, FHs are here. Row AB are here. Row CD is here. Notice I didn't say anything about these columns, and I didn't say anything about these rows. That's how we go ahead and do this. Now let's look at some of it with actual numbers. Might make it a little bit easier. All right, so here we have R and S. 2 by 2 times a 2 by 2. That is something we can go ahead and do. So we're going to go ahead and do some multiplication. So row 1, so here's our two numbers. So row 1 again is 3 and 2. So if I'm looking at this first spot here, I have the 3 and the 2. I put a plus in between them. And then I take the column here, -2 and 1. -2 goes with the 3 and 1 goes with the 2. The first number with the first and the second with the second. So 3 with -2 and 2 with 1. Because this is row 1, column 1. Now this spot here is row 1, column 2. So we're going to take row 1 with column 2. So the 3 goes with the 1 and the 2 with the -1. So 3 with the 1 and the 2 with the -1. So row 1, column 2. Now if I'm going to move on to the one down on the bottom here, now I'm dealing with row 2, column 1. So row 2 with column 1. So row 2 is -1, column 1 is -2. So -1 with -2, and then 0 with 1. 0 with 1. And then the last one, again this row with the now column 2. -1 with 1, and 0 with -1. Notice that there are two sets of multiplications for each one that we are going to add together. That was what I was talking about way up here at the beginning. The inside number is the number of multiplications that we have to have and to be summed in order to find the individual entry. So when I'm coming all the way back here, this is a 2 by 2 times a 2 by 2. So there's two, the 2's are the things that are in common in the middle. And since they're in common, notice I'm going to have 2 sets. Each of these has 2 sets, 2 and 2. Once we've done all that, we're just going to add these up. This is -6 and 2, and 3 and -2, and so on and so forth. And we just add the individual spots. So here we have -3 and, I'm sorry, 3 and -2, which is -6, plus 2, which gives us -4. And 3 minus 2, which is 1. And 2 plus 0, which is 2. You gotta like the zeros. And -1 plus 0, which is -1. And so this is my answer. It's a bit of a long way to get to there, but that is how we do multiplication. Let's try some more. Ooh. All right, so I color-coded this one, if it helps you. I made R red and S green. And it looks like I lost some here. We'll get that in just a moment. So row 1 is 3, -1. So 3 and -1. See, I have them here, and 3 and -1 again. And then row 2 is 1 and 0 and 1 and 0. Column 2, -2, 2, -2. Columns here. And then 1, and these should have been 2 -3s over here. It got cut off some reason. And once I have that, then I multiply it and give me 6 and 2, which gives me 8. And then 2 and 0, which is 2. 3 and 3, which is 6. And 1 and 0 is just 1. And so my answer is 8621. Now, here's one that's a little bit different. This is a 3 by 2, and this is a 2 by 1. So they can be multiplied because the 2's in the middle, and my answer is going to be a 3 by 1. So I'm going to have a 3 by 1, so I'm going to have 3 rows with 1 column, and each column is going to have 2 sums because that's that middle number. So each column has 2 sums. So the first one is 5 with 4, and then this column is 3 and 1. Notice the 3 and 1 is on all of them. The first column is 5 and 4, the next one is 6 and 3, and the next one is 4 and 5. Multiply those together, add them up, and we get 19, 21, and 17. All right, K times L. This is a 3 by 2, I'm sorry, a 2 by 3, and a 3 by 2. Notice the middle numbers here are 3's. So that should mean that we are going to have 3 numbers that we're going to have to add up. So how is that going to work? So my answer is going to be a 2 by 2. So notice here, I'm going to have 3 numbers I'm going to have to total up, and 3 and 3 and 3. So I'm going to do -3 with 1, which was that -3, and 2 with 4 for 8, and 2 with 0, which is 0. So because there's 3 numbers across and 3 numbers down, I'm going to get 3 sets in here. Answer is still going to just be a 2 by 2. And then the bottom row, -1 times 1, and -2 times 4, and 0 times 0. And so we add those all up, and 5, 10, -9, -4. Now, what happens if we switch that around? What if we do L times K? How does that change things around? Notice now it's a 2 by 3. It's a 2 by 3 and a 3 by 2. They have that backwards, don't they? That's still KL. So this was back. It needs to be backwards. This should have gone first. And what that ends up giving us is a 3 by 3. But the 2's are in the middle, so we're only going to do groups of 2. So LK, we have to use these rows because L's first, and then these columns. So 1 with -3 and -2 with -1, giving us that first spot. And then row 1 with column 2 for this middle one, and then row 1 with column 3. Now, this is how we do it by hand, and obviously this process is very long and difficult to do. Not difficult, I guess, just time consuming. A lot of silly little mistakes can be made and things of that nature. So if you want to go ahead and take a look on how to do it on your calculator, feel free to go ahead and do that, or of course on the Desmos app. And we get this 3 by 3, but you notice this was a 3 by 3. The last problem was a 2 by 2. So matrix multiplication is not what we call commutative. It will not give you the same answer. So like if I do 5 times 6 or 6 times 5, that's commutative because it gives me the same answer. It's 30 for both of them. So the order doesn't matter for that multiplication. But for matrix multiplication, it does. It's not quite the same, which obviously you should have a good idea of already. And I can even do things like this. I can do A times B plus A times C. So I'm going to multiply A and B first, and then A and C. And then when I'm done multiplying them, I can add those two together. And you can put this all in your calculator. You can have A, B, and C, and just type in this formula here, and the calculator will figure it out for you. So I have to do A times B plus B times A times C. We're going to multiply all those together. 2 by 2's, I'm going to get 2 answers. I have to add those together. Get the 5, -4, 5, -2, and then we just add them together. There are 2 by 2's. We can add them together. 5 with 1 is going to give me 6, and -5, -2, and of course 0. So we can do a bunch of these different things together. We can multiply and add, and we can even do some scalar multiplication if we wanted to. And that's what I have for you today.